welcome everybody. My name is Hugo Lopez, and today I'm presenting a paper with Marie Yusudenga, Rasmus Thompson, and Martin McCart on the declarative process models, which is thinking processes and textual views. And overall, what's the approach? I don't know if some of you have been in the tutorials from yesterday, where Jan was presenting that a process is basically more than its model, and we have different artifacts in order to make sense, to analyze, to do reasoning about a process. And some of those artifacts are, in this case, textual views and model views, and they work for different purposes. Now, what we would like to do is to ease up the transfer between one view and the other by either generating a process model from a textual view or linking the process model to the textual representation. And well, this is not a simple thing, because if you want to apply, for instance, my techniques of process discovery, well, process discovery has always been used by taking a very structured notation, a very structured artifact. So in this case, event logs. When you move from event logs to unstructured artifacts like natural language descriptions, then things stop being so simple. Some of the problems there are lack of generalizability. You would have some textual patterns that describe certain things, but then when you move from a different content, for instance, if you're going from interviews to laws, then the patterns that you have used to mine what was the process of presentation stop being useful. That also is a challenge when you change of authors, so a writing style, length, or complexity becomes aspects that we need to tackle. Then the second part is on the reconciliation. So having the model and having the text, how do we link these two things together? And then we need to understand what constitutes a process element within the text, and what parts they don't really add value to the process representation. So let us, in the sake of time, we only have 5 minutes, so I'm not gonna go very deep into what with the full spectrum of the complexity of the challenges we have in the paper. But I'm going to show you a couple of examples where complexity becomes a tricky part. So the first thing is on the many-to-one correspondence. So you see on the one side a couple of process textual descriptions, and in the right side you have a process model. In this case, a declarative process model represented by a DCR graph. And what you would like to do is to identify that you have a different process elements, different textual elements that correspond to one given process description element. So in this case, clerk, the clerk, and he, they are actually corresponding to the same role, clerk, in the right-hand side. Same thing for activities. So in an activity here, the claim is closed, and closing the claim, they are actually the same activity, close claim in the DCR graph. The second thing is about atomic and compositional alignments. Well, some process elements can be identify what a given utterance, like receives a claim, that corresponds to receives a claim as an activity in the graph. Some others, they require information, a composition of different information elements. So in this case, a constraint, a rule, is not a rule per se without having been earlier identified information like the different elements, different events that this rule is trying to constrain. The third thing that we have is the normative versus learned interpretations. So traditionally, rule-based approaches, they have taken a keyword and assigned that to a given semantic, intended semantic. For instance, a may should be represented by a constraint that describes a condition. However, when we see process descriptions, we see that this the semantic representation, it changes given on the context. So if you see the right-hand side, the agent goes from confirm the claim to the clerk to 2 different places, issues the money, order for the claim, and supports the customer with additional assistance. They are actually the same representation to the if then else pattern. However, in some places, the intended meaning was a composition of different rules, a conditional response in this case, and in other cases, just a condition. To give you a couple of examples of what has been presented in the state of the art, some of the papers have been presented already in CAiSE this year or previous years, but you can define this into two different approaches, either rule-based approaches or machine learning approaches. With rule-based approaches, we go on a syntax-driven approach in which we have some keywords, we have a dependency tree, and then we try to assign that to a given meaning representation, but we have problems on ambiguity. A couple of examples here is, for instance, this sentence: when the company receives a new claim, Declarative opens a claim and supports a customer. And we don't really know whether the consequence opens the claim and supports a new user. They should be aligned in either a sequence pattern or in a parallel pattern. The other one is also regarding context, which is, for instance, the noun, the word, the noun he. This pronoun cannot really be represented without us knowing what was the earlier agent, in this case, a co-reference. The other part, the other type of papers that we have seen are machine learning-based approach, and these are actually prone to a good generalization. But what we have seen so far is that until at least 2021, there has been lack of data sets that are process specific for natural language processing. So we have seen a lot of approaches that are taking, for instance, cooking recipes or maintenance manuals, but they are not really considering all the complexity that we have on real process descriptions.
Yes, and for the proposed framework to solve this business discovery problem is that we have an input, which is a process description, and then we have a pre-processing phase. Afterwards, we have discovery reconciliation phase, which consists of two different approaches: a rule-based feature extraction and a machine learning-based feature extraction. The machine learning-based feature extraction is consisting of a pre-trained BERT models in which we input our 37 process descriptions. The pre-trained BERT model then output three different BERT models that we use: a relation identification, relation type identification, and a name entity recognition model. Then both these two approaches are then combined together, mainly by intersection, in which we then get outputted a processed model, and an annotated data. The key features of this approach is that we generate declarative models and traces their relation in textual artifacts. We reduce the time that process models will spend mapping business processes and works on multiple domains with little to no pre-training needed. Our initial validation then it consists of a mixed data set that we created using 5 process descriptions from HTTP, 5 process descriptions from Declare, and 5 process descriptions that we excluded from our own training. We define a match when there's a process element linked to a textual description. The predicted fragment corresponds to a manual annotation. And finally, this algorithm is part of the process highlighter, the hybrid process representation tool. It combines the text and the declarative models. It's also part of the offering and the DCR solution. It's open for testing with academic license. The dataset and experiments is available in GitHub. Thank you for the time.
Thank you. That was a bit too long, your presentation, but I understand you want to share all details. So we can have one question before letting people to move to other rooms. Do we have someone with a question? No. Okay. So how much automated will be your approach? So do you mean from textual description you can get the model, or somehow the people interventions still necessary to mitigate or to make decisions or to clarify things?
Well, in the paper we have we presented an algorithm that does the full automation. In the tool we have 2 modes. In the one, basically we would like to also prevent that there's some false positives. So we can also check whether each of these rules, check of these actors and the like, have actually been true positive or false positive. So the user can go and check each of the suggestions whether they are correct or not.